All right, welcome to CS50. This is the start of week 9. So one announcement, if you haven't RSVP'd already and would like to join us, Wednesday, Mather, 6 p.m., do just RSVP. One new handout today, and this is a bug of sort, or a feature, if you will, that's actually been circulated a bit on various blogs this past week, though it's been around for some time. I thought I'd replicate it here with this website called Google. I was wanting to do some math the other day. And it turns out that Google does math. For instance, if I want to know what 3 minus 2 is and hit enter, well, we'll actually do that kind of math for you. But that I can do in my head. But I can't really do in my head very well. Something like this. That's a big number. And then let's just minus. Actually, let's try to be creative here. Let's put almost the same number, but 998. OK, so for anyone who's taken like Math 55, what's the answer? 7. Excellent. So it's pretty close. It should be 1, right? Pretty big numbers, but one's just one bigger than the other. But if you do a little Google search for this, the Google fails us. So I know. So this went around a while. So this isn't a bug per se, because otherwise someone at Google would have addressed it, because it's been blogged about ad nauseum. So what might the explanation be? What's that? So rounding, or there's some kind of imprecision here. So even though we talk mostly about this in the context of floating point values, so even with integers, we've seen in C at least that there are upper bounds on the kinds of math that we can actually compute. So if you like this kind of thing, so there's really no big lesson here. This is, in fact, a feature of the way math is implemented, at least by Google here. But there's actually a neat article that's been recirculated. It's called Why Computers Suck at Maths. It's an interesting article, actually, and it discusses this and other such things. So we've linked that on the course's website if you would like. Also on the course's website now, we've replaced the old big board with the new big board. Old big board's still linked there. You'll see that your classmate Charles has already figured out how to exploit financial opportunity, perhaps. More likely bugs or weaknesses in our own implementation of this big board. This is sort of this funny thing, especially about teaching a Harvard class, right? No, you just want to do something nice and fun that gets the students excited about this and that. It's completely ancillary to the P set. And then there's always one or more people who decide, let's see what we can break. And of course, there are weaknesses in this, and that's fine. Charles is up 4,000% since like 9 a.m. this morning. If you actually look at his history by clicking his name, you'll see exactly how he did this and what he bought and things we probably shouldn't have let him buy. And again, you can essentially see into the future if you simply watch your own E-Trade account or CNN.com and then make your purchases within the 15-minute window that is the delay that Yahoo Finance imposes. But that's OK. Why don't we just throw down the gauntlet and say that Charles is now the person to beat? So 433,000 is currently the #1 position. I think I'm doing rather the opposite. Oh, actually, we're only down 1%. But one takeaway that's worth noting here is, and you may have glimpsed it really fast just now, is this is actually an Ajax implementation of this big board. Ajax is kind of a buzzword, but it refers to websites that are more dynamic in that to update the page's content, the whole thing doesn't have to reload. You can just reload portions of the page, thereby creating a much more seamless interface. And that's going to be one of the topics for this week. How can we move away, even just 1 week later, from this very mechanical but very reliable approach of implementing websites where one page leads to another, and can we make this user experience a lot more seamless like this? And if you watch this over the course of several minutes, you'll see that these numbers do in fact fluctuate. And I wouldn't be surprised if by the end of today's lecture, someone is already contesting Charles. So we shall see. Oh, and also back is Ceiling Cat. Ceiling Cat is one of the most famous lolcats. I know that the feelings on this topic in the course are mixed, but seeing as in the remaining surveys that were submitted for PSET 5, which we finished reading through, one student actually said that he or she registered for the course because, my God, the syllabus was online in advance, and so few courses do that. And another student literally wrote that he or she enrolled in the course because he or she saw Ceiling Cat on version 1 of the website. So we actually removed that, and worrying that it would work against us this year, but we'll put him back since this is now the web week of the course. And if you actually click him, you can read about the beginning of the Earth from Ceiling Cat's perspective. So this is another famous link there. Anyhow, all right, so what do we got in store today? So last week we talked about Last week we talked about PHP and a little bit of MySQL and HTML, and PSET7 is really going to enforce this stuff. So we're going to forge ahead this week and give you the conceptual framework for both PSET8 and probably for many of you final projects. And as much as we've kind of promoted taking a web-based approach for final projects, realize you absolutely do not have to. We just know historically in recent years 60% plus of students in the course tackle web-based final projects, even though we spend but 2 weeks of it officially in the semester. But you are welcome to pursue most anything per the final project specification. So I thought I would either try to really excite you or really crush you with the following promise, which is that we can implement the entirety of problem set 6 essentially in one line of code. So that's a bit of an oversimplification, but it does speak to this issue of choosing the right tool for the job. So what I went ahead and did was the following, and included among your printouts for today is this file called Speller. So notice a couple of things. Speller 1 has no file extension. So even in the course, we've had this habit of using file extensions like .c and .h. For the most part, those are just conventions. Now, with that said, some operating systems like Windows rely on file extensions so that when you double-click it, it knows what program to load. But operating systems like Linux and Unix and Mac OS are a bit smarter than that, and they actually look inside the file to figure out what program to launch. But there's still this convention of naming things with file extensions. But it's not necessary. I proceeded to write this program called Speller, no file extension, but notice no zeros and ones. This is not a compiled program because I wrote this one in PHP. So the catch when you write a program in PHP, especially if you just want to run it at the command line, like I did early last week when we did that very simple stock quote checking program, the 4 or so lines of code, I ran it at the command line as PHP space quote.php because I wanted to use the PHP interpreter, a program that executes PHP code, and I gave it a command line argument, the name of the file I wanted to execute. But that's a little bit annoying because now your users have to realize, oh, this program happens to be written in a language called PHP, even though I don't care. But just to run this program, I need to know to run PHP space file name. Well, you can avoid that altogether on a Mac or on a typical Linux or Unix system by including this thing atop the file. So this is what's sort of goofily called a shebang. S-H-E-B-A-N-G, which just means put the sharp symbol at the top, followed by bang or exclamation point, followed by the path of the program that you want to use to interpret the following lines of code. So simply by including this at the top of my file and by running this command, chmod, change mode 700 of Speller, and this command chmod is discussed if you haven't read it already in PSET7, this is going to make my file executable. And what this means, if I do an ls, and this is just an aesthetic thing, Speller is shown to me in green and with a star, at least within PuTTY, the program I'm using on this PC. So that just means it's executable. So that means I can run at the command line Speller, or more specifically, just to be really security conscious, /speller, run this copy of Speller. So what the OS, Linux in this case, is going to do is it's going to see, top line of this file says use the following interpreter, user/bin/php. That's just where it is on the hard drive. Let me load that program and then feed the following lines to it. So the same goal is accomplished of executing the code, but it's a little more user-friendly that now I don't have to know or care what language this is written in. So I implemented Speller, and if I run it like this, I see output identical to PSET6's framework that you guys were handed. So we won't walk in great detail through this. You're welcome to do it sort of at your leisure at home. But notice I pretty much tried to look at my C code on the left-hand side in a window, and then I had another window open for this file, and I tried to literally translate C code to PHP code. Partly so that you guys, if you want to curl up with this at some point with your old PSET6 or PSET6 still in progress, you can actually see how you would implement the same program but in a different language. And most of the syntax is familiar. So at the very top here, I have require. So require is similar in spirit to that sharp include. In C, it means require the following file. Copy and paste its contents here. So this thing here is a little PHP specific. PHP, like a lot of languages, have different levels of error reporting if you really want to get your hands dirty with the feedback from the program. So I'm just saying turn on, suppress things called notices and warnings. In a lot of languages, there's at least 3 types of bad things that can happen. Notices, which are like, you really shouldn't do that. Warnings, which are, are something bad probably happened, but I'm going to proceed nonetheless. And errors, which means, sorry, really bad stuff happened. I can't even run your code. So there's different levels. In C, we pretty much turned everything into errors for you guys to force you to actually deal with them. So for now, you can just kind of take this one on faith. This I stole from the problem set. I defined a constant in PHP. Syntax is different. It's not sharp define. It's define. And define is actually a function that takes two arguments, the name of the constant and then the value you want to give it. But otherwise, it's the same idea. Same deal for the second constant here, words. And then down here, notice that just like in C, I can have command line arguments. So if argc does not equal 2 or 3, tell the user how to run this program. So it's pretty much been a copy-paste from C to PHP, but I've changed my variables to have $signs, and I've changed how I declare constants. But pretty much, it's a pretty good translation. Now, this thing here I did just to be a little bit anal. So these are the variables we had in Speller as well, ti load, ti check. And I've initialized them just to be a little fancy to 0 dot. Now, this is just me thinking I'm being clever by just saving a character, by not doing 0.0, but it's the same thing. As soon as you append a period to a number, it becomes a floating point value. So, and I also just didn't want to waste 4 lines of code. So again, stylistic decision. I just put them all on the same line separated by semicolons. But it's the same approach as in C. But notice I did not have to specify for any of these variables what? A type. So again, PHP is loosely typed, which means there are data types underneath the hood, but PHP gives you so much automatic conversion or casting from one to the other that you, the programmer, don't have to worry as much about it. So this is our little tertiary operator, question mark and colon, which just says if argc is 3, assign dict the value of argv1, else assign it the default value in that constant. And then for the most part, the rest of this you can play with or look through on your own if you want, but it's pretty much a translation of the benchmarking code that you guys used for problem set 6. And the end result at the end of this program is that it prints this output, which should be vaguely familiar at this point. So in short, I re-implemented Speller in PHP. But of course, you didn't implement Speller. You implemented dictionary.c and maybe .h. So you implemented only the data structure. So I thought we would kind of do that here. Let me go ahead and move this one aside for just a moment. I'm going to create a file called dictionary.php. It's automatically going to be included when I run Speller because of that require line. Every PHP file has to begin and end with this, or anytime you write PHP code specifically, you need to encase it in these things so it's not conflated for HTML or something like that. So let's see. I need to implement a whole dictionary. And let's see, what was in there? So I had a function that I had to implement called load, and it has to return a value. I had a function called check, and it took a word, and I'm going to have to write that. I had a function called, there were 2 more, size, and that's probably pretty easy, but let's see. And then finally a function called unload. So these were the 4 functions I implemented, and pretty much we gave them to you as blank, maybe a return value here or there. But I need to implement the data structure first. Well, in PHP and some of these high-level languages and scripting languages, you can implement data structures yourself. You can implement trees and tries and hash tables. But the thing is, you don't have to, because in a lot of higher level languages, you're handed this stuff for free out of the box. It's a feature of the language. And in fact, we mentioned this briefly last time, that thing called $_post or $_get, that's super global, as I labeled it last week, that's what's called an associative array. The syntax for that, recall, looked a little something like this. Post, and then I could say something like name, and what that variable gave me is the value that the user typed into a form called name. Now, we're mostly familiar with arrays in a numeric sense. In C, we always did something like this, or like this, or like this. But what's nice about an associative array is that it's a generalization of the idea of an array, and you can index into the array using things other than numbers. You can use arbitrary strings. So in fact, what an associative array is, it's kind of like a 2-column table in memory, where on the left-hand column are keys and the right-hand column are values. But what's really nice about the language itself is it doesn't search these things linearly. What an associative array is implemented as underneath the hood is something like a hash table with chains, which is what many of you, but not all of you, use to implement your implementation of pset 6. So long story short, if I want an associative array, aka hash table, I simply have to do something like this. Give me an array. So this is going to be my hash table. It's as simple as that. So now I can put stuff into this array, and I can get stuff out of this array just by using that square bracket notation. So let's see. What else am I going to need? I'm also going to declare a global variable called hash table size. And I'm just going to call this size, and I'm going to initialize it to 0. So notice this is outside the scope of those functions. So now all I have to do is implement the remaining functions. Well, let's kind of impress just by being quick here. All right, done. So we're done with that function there. So we have 3 functions left. What about load? Well, to get in load, oh, and actually I forgot one thing in load. It did take a command line argument, the name of the dictionary to load. My goal here has to be to load the dictionary into memory, and then iterate over the files, and then insert each of the files into my data structure. Well, how can I do that? Well, it turns out that in PHP, there is a function called file, which returns to you an array such that every element of the array is a word from the file. So it literally gives you that. In fact, let me do a quick little, let's see what I want to do here. Let's do a quick sanity check. I'm going to go ahead and do this, and I'm going to say, call this a variable called lines equals file of dict. And this is going to get me, again, an array whereby each element is a word from that file. And again, now this is sort of debugging mode. I'm going to use that recursive print function from last week. I'm going to print lines, and then I'm just going to exit. So this is not a working implementation, but I know Speller's going to call load, and I just want to see what's inside this variable temporarily, and then we'll throw away these 2 lines of debugging code. So let me go ahead and save this. And let me go ahead and run Speller on a very small file, something like the Ralph Wiggum quote, and hit Enter. And in fact, that's what I see. So what you're seeing being spit out again and again, because I'm recursively printing the array, is a list of all of the words in the given dict file, in that default dictionary. And you probably remember at least the last one, if you ever saw these things flow on the screen. Well, also, there's a weird artifact here, whereby there's a space between every line, and that's because there are new lines in the file. So but we'll deal with that in just a moment. Well, it turns out if I'm getting back an array here, I'm not even going to bother assigning it to a variable, because I'm going to immediately launch into a for each construct, for each word from the file. And the syntax for doing this is this. This is a nice little piece of syntax that doesn't exist in C, not this user-friendly like, and it's going to say for each of the words in that array. So it takes an array in parentheses, then the keyword as, and then the name of a variable that you want to update on every iteration being the current word from that array. So this is going to induce, the equivalent of a while loop or a for loop, but it's kind of nice and compact in what it's going to do for me. So what do I want to do? Well, I need to remember that each of these words is in the dictionary, but let's see how I can do that. Here's my hash table, dictionary. Well, I pretty much just want to do this. I don't want to index into an I location because there's no variable I, and I don't want a hard-coded number. What I want to use is the word as a key. And you know what? It suffices to say this. OK, insert this word into my dictionary, but just say true. So I'm treating word as a key, true as a value, so that if you now fast forward in your mind to the check function, how is check going to check whether there's a word in a dictionary? It's just going to check if the given word exists in dictionary, because if it gets back an answer of true, I put it there. And if nothing comes back, that means I didn't put it there, which means it's not, in fact, a word in the dictionary. So before we clean up this function, let's fast forward and just do this. Return dictionary, bracket, word. And actually, let's be a little more anal than this. So if I find a true value at the location in the dictionary, go ahead and return true. Else, go ahead and return false. So this function's actually done. If the given word is in the dictionary, return true, else false. Now let me just clean this up, because I did say that there were these new lines at the end of the file, right? Because the default dictionary has word, new line, word, new line. So there's this other function. And this is really just useful. Chop. The behavior of chop is to eliminate the last character from a word. Or I could use something called trim, which eliminates white space from the end or the beginning of a word. So I'm just going to clean up my word in this way. Actually, let's go ahead and use trim, just because it's a little more thorough. And I know it's just going to get rid of white space on the beginning and end of a word. All right, so I'm pretty much done. Actually, you know what? Let me do this. I now need to say return true. OK, it turns out I don't really need these things. Let's make the code look even smaller. And let me do one reasonable sanity check. So if file exists, this variable, actually, if this file does not exist, or this file is readable, these are literally functions in PHP. What do I want to do if the file neither exists or is readable, or is not readable? Yeah, so return false. So now I'm adding a modicum of error checking here. But I'm pretty thorough here. So if the file doesn't exist or it's not readable, return false because I can't load the dictionary. Otherwise, iterate over each word in the file and then insert into my hash table every word and just assign it a value of true so that later I can ask Boolean questions. Is the word there? Yes or no? Yes or no, iteratively in my check function. Now I need to change one thing. There's one nuisance of PHP, which is that even though dictionary looks like it's a global variable at the top of the file, you actually can't access global variables inside of functions unless you say, hey, PHP, dictionary is a global variable, just so you realize. And so I need to do this in here, I need to do it in here, and I need to do one other place. I need to do this here. So it's stupid, frankly. This is an annoying feature of PHP, but at least now we have access to that global variable. Unload, is there anything to do? No, not really. Already unloaded. In PHP, you don't have to manage your memory. The PHP interpreter does it for you. No malloc, no free, none of that. It's all done for you. So any concerns? Did I make any mistakes? Because I literally am doing this on the fly here. Good. It doesn't. It's always going to be 0 right now. So what do we want to do to fix this? Yeah, might as well go in here. I guess I got to put my brackets again. And then I'm going to do size plus plus. And I just have to make one other change here. I have to specify that size is global. Yeah? Good. OK, and we could do this any number of ways. So let's save this. Let's run speller on texts and now run it on the Ralph file. And that's wrong, isn't it? Let's do I want to do this right now on the fly? File exists for each file is word, dictionary trim word. That's OK. Size gets true. Can you see the bug? What? Capitalization. Oh, yes, thank you. Thank you very much. Capitalization. OK, so that's I can fix. Stir to lower. Right, I mean, frankly, you laugh, but this is one of the biggest sources of bugs in your C code, right? Was given the check function, most of you probably made a copy of the word, then had to force it to lowercase, then you had to chase down all these stupid memory bugs. But, I mean, this is actually very reasonable because I'm past the word. It could be in any type of capitalization. I want to force it to lowercase, so stir to lower is, in fact, the function for that. Let's go ahead and rerun Ralph, and yes, it actually works. So what was that? 8 minutes of coding to implement problem set 6 in the better choice of languages, but surely there must be a catch. So in fact, there is. So let me actually not run Ralph, because recall, Ralph is a terribly short file. Right? This is, and if you never actually looked in this file, this is the, so from the laughs, you didn't actually look in this file, some of you it seems. So that's OK. So let's take a look at speller, though, on something much longer like the Holmes file. So this is like 6 megabytes. So this was a very large file. It's going ahead and spell checking, spitting out all of the bogus words. And let's give it a little bit here. There were a lot of misspelled, quote unquote, words because this was an unfamiliar text. All right, so words misspelled 17,000 out of 140, out of actually 1 million words in the file. So this is a big file, and it took roughly 2.19 seconds to totally spell check that file. So now let me shift gears to my other window here. Same server, I'm on, logged in as myself, and I'm actually going to run not the PHP version, but the staff solution from pset 6 itself, which was called speller here. I'm going to pass it the same text file, which is misspellings, texts, Holmes. So again, I'm just running the C implementation now of the staff's implementation of dictionary. And I'm going to hit enter. And wow. So maybe it's that the staff is much better at writing code than I am, right? Especially since I just wrote this on the fly. Or maybe it also has a little something to do with the choice of language. So this is one of the trade-offs. And again, this theme of you don't get anything for free. So yeah, I really whittled down my development time from what? 10 hours, 15 hours, 20 plus hours for some of you to 8 minutes, which might be a little disheartening, certainly. But look at the price I'm going to pay in the long run if I use this thing to spell check very large bodies of text. So development time went down, but running time significantly went up. I mean, notice the difference here. Notice the bug here. OK, we'll ignore that little detail that the words misspelled is slightly different, because there is, in fact, a little bug somewhere. But trust me that it's the choice of language. I should get credit for pointing out the bug and not letting you realize it, maybe. So Notice the order of magnitude, though, 2.19 seconds versus 0.4 seconds. And this was still a relatively small file. It's only 6 megabytes, and we deal with much larger data sets these days. So what's the takeaway? Well, the theme in interpreted languages like PHP or JavaScript or Perl or Ruby or Python, there's a whole bunch of popular interpreted languages. They're very convenient, and they give you a lot of features out of the box for free so that you don't have to reinvent the wheels you guys have been implementing all semester. But you really pay for it. One, you have no idea how things are implemented underneath the hood, which may or may not be a bad thing. But certainly you can't fine-tune your code very effectively. And if the goal, especially for a job or for your research, is really to maximize performance, you really need to pick up the right tool for the job. Yeah?
So when you kind of reference a place in the table in C,
Mm-hmm.
isn't there, the segfault?
Mm-hmm.
And here, if you're basically referencing this table and it's not there, you don't have that problem?
That's correct. So, and I'm also taking advantage of certain features of the language. So the point here is that in my own dictionary implementation, and let me open my commented one, which you guys have a printout of. So in my implementation, notice that in my check function, I'm kind of blindly checking if there is, in fact, a word at a given location in my dictionary, but there might not be anything there. And as you point out, in C, very bad things happen if you just index into an array anywhere you want. So in PHP and in a lot of languages like this, that's not a problem. You will simply, by default, get back a value of false, or it will trigger a warning or some kind of notice. And in fact, I'm being a little tricky here in that the line of code that I mentioned at the very beginning of Speller that suppresses notices and warnings, what you describe, indexing into an array where you should not, that in PHP actually triggers usually what's called a notice. You will see printed on the screen, notice, indexing into an array, not wise, or something to that effect. But with this line of code, I'm actually suppressing that notice because I'm very comfortable accepting that I know there might not be anything there. So with this case, I'm telling PHP, quiet. I don't want to know about these notices. This is OK. But there are other ways to deal with this. You could actually do something like this. So let me make one last comment on this, and then we'll forge ahead. I could have done this. If dictionary stir to lower word is set. So there's a function in PHP called isSet that solves exactly the problem you are worried about, which is it checks before actually going there, is there anything there? And only if there is does it return a value. Yeah?
So then why bother with the line underneath?
So I wouldn't. I would replace one with the other at that point. I would replace one with the other. So, but I made the conscious decision to kind of gloss over some of these details just in the interest of simplicity. But frankly, it's reasonable to do such if you know what you're doing as a design decision. Other questions? OK, so then a word on why did we just put you through problem set 6 and problem set 5 and problem set 4, right? So one, there are different tools for the job. Like when you are doing various research things, or if you are trying to actually implement the next best search engine or whatnot, you really do sometimes want to get very low level, closer to the operating system and to the hardware, so you can actually eke out as much performance as you might want. But there's also something to be said for actually understanding what this thing is. I would argue that there's a lot of software developers out there who completely take for granted that there is this thing called an array. You can index into it, but have no appreciation of how it's actually implemented underneath the hood, and therefore when to use it and when not to use it as well. And also, it's around this time of the semester, especially with PSET 6, where late day usage really spikes. So not to worry if you're kind of still working hard on PSET 6. It's typical, especially at the end of the semester. But realize the common sentiment at this point in the term is, my God, like, thank God the end is in sight. And, you might feel like you've learned something. You might feel fairly gratified at 4 a.m. after finishing these things. But many of you might think, this isn't really for me. I don't want to go through that again. But realize that is not necessarily what programming is and what programming computers is all about. So now that we're finally taking this step up, realize that there is this great element of fun, I think, of programming that allows you to solve real-world problems, whether it's some news site, again, our events site, the Twitter site, relatively easily, including simple things like the spell checker. So you simply have to pick the right tool for the job. And that's why I think final projects around this time of the year tend to be particularly fun, because you can finally actually bite off something that you're choosing and not us. So that was a lot. Why don't we take our 5-minute break now? All right. So So it's kind of spooky that it's already time for this little announcement, but indeed, even though a month or so remains in the semester, do realize that we'll already be on the search for TFs and for CAs for next fall, 2010. Know that the role of TF involves leading section, working with your students, grading their problem sets, office hours, and the like. And CAing, by contrast, is a role that we've targeted particularly at alumni of CS50. So almost all of the CAs that you may have met in the lab or on email lists this year are former CS50 students who have offered to contribute 2 hours, only 2 hours of work per week on a volunteer basis, working with their fellow classmates and their successors in this class in the lab in what is pretty much the most intense fun part of the course in office hours. Realize that if you do choose to join us next year, it's a little more fun being on the other side of things and actually running the whiteboard and not running to the whiteboard. So just go, we'll post a link on the course's homepage before long via which you can apply by telling us a little something about yourself and what you plan for next term. So in the time that has passed, Charles has made, let's see, about, what, $60,000 more dollars. So he's doing quite well. So we give him our official blessing and challenge you to best him. But realize this thing exists, one, just for fun, but also so that you can actually play with the staff's own implementation of CS50 Finance, which you can get to by following the appropriate link here. But realize, too, you need not implement your version of PSET7 exactly as the staff has. We have simply offered it for consideration. And as you may have realized already, you can look at some of the code for the site. You're welcome to look at the HTML and the CSS. What you'll find is that you don't have access to the PHP, and this is kind of a rule of thumb with web development. It's pretty reasonable, and it's technologically completely possible these days to look at other people's source code with regard to HTML and CSS, and even, unless they've jumped through some hoops, JavaScript as well. And I can't emphasize enough, if you like this kind of stuff, the best way to learn about how to do new things is to look at a site you like, and even though it might be a little complicated at first glance, start poking around with its source code and learn from someone else's site. There's really not much intellectual property when it comes to XHTML and the layout of a site. The juicy stuff is in the JavaScript, which we'll see today, and also in the PHP, the former of which we can actually obfuscate in some way to make it harder for people to take your intellectual property. But let me bring your attention to this thing here. So PSET7 recommends that you install a few free tools, and we encourage you to use Firefox only because it's really useful for development purposes, but ultimately you should be testing, as the spec says, your code on multiple browsers, because this is a very common thing for, you will find the hard way, unfortunately, that the web browser manufacturers have always been at odds for years, 10, 15 years now, where Microsoft interprets something in the specification for XHTML one way, Mozilla interprets it another way, Apple interprets it another way. So you will see slight differences, even on your relatively simple websites, across multiple browsers. And one of the things that drives us nuts for the course's website is making it look as best we can the same, no matter the OS and no matter the browser that your user is using. So we do expect that you play with at least 2 browsers for your project, but with Firefox, you have some really useful tools. So I have this little bug at the bottom of my window because I installed an extension. It's free software for Firefox called Firebug, and it's a few different things. It is it allows you to view the websites, whether it's yours or someone else's, XHTML or HTML, in a much more user-friendly way. So notice what I've done. After clicking the bug, this little pop-up opened up, and what it's showing me with much nicer indentation and nesting the structure of this web page. By contrast, if you look at the course's website, it's an absolute mess underneath the hood, not because we were lazy and didn't really practice good style, but because a lot of the website is dynamically generated by PHP scripts that we wrote. And even though we kept our PHP code and our JavaScript code pretty neat, when you start to combine all of these things, things just get messy. And there's really no point trying to make this look clean, because for the most part, it's only a browser that has to understand this. So we elaborated on this in the PSET spec. But for learning, this is frankly a bit of a nightmare, trying to find your way around this. And even when we re-implemented Google last week, I relied on Control F just to find things in the document. But Firebug's useful for XHTML and HTML for this reason. You get a much nicer view of the world, which means if I want to see what's going on in here, I can actually dive in and click on these pluses. So it looks like the body of my page has this thing called a div, which I've given an ID of wrapper. There's a table in there that's laying things out, a table body, a bunch of table rows. And more interesting is this. If you start to hover over tags, you'll see top left in blue what it is I'm hovering over. So apparently we are actually using very deliberately an invisible table whose border is 0, thereby making it invisible. So notice this TD, this table data element, is the white space at top right. If I scroll down a little further, this guy here is apparently that bar in the top middle. And as you might guess over here, that's the guy on the right-hand side. If I dive into the next table row, notice, there's the left-hand side of the page. Here's the middle. Here's the right. And so if you see something on a website that you like, or you wonder, wow, how did they implement this? It's really cool. This is a wonderful way of actually wrapping your mind around how they did it. Now, CSS isn't something you need to worry so much about for the course. But if you're coming to the course with some background, realize, too, that Firefox lets you see the CSS that's being applied to a site. If you click on an individual element, like this one in the middle, on the right-hand side, you will see all of the CSS rules that have been applied to that element. And from top to bottom, you'll see how they cascade. So again, I won't spend much time on this only because it's not all that enlightening intellectually for the course's purposes. But this is a very common technology. But for the most part, it's not necessary for our two problem sets. But realize this is there. And finally, which we'll start using on Wednesday this week, we have a script tag, which actually lets you debug things that happen to be written in a language called JavaScript. So this will be invaluable, too, to think of this as a GDB substitute. And also useful is one other thing. So on the course's website, we have this link here to web. Firebug is what I just mentioned. Firefox is the browser. Then there's this other debugger, which we'll may talk about a bit on Wednesday. Then there's this thing, which we will talk about today, live HTTP headers, and then web developer. This web developer toolbar is what gives me this menu here. And it also appears under your tools menu. So very important these days, or very common, is for a website to be designed with a specific browser size or window size in mind. Most common these days is probably to assume that a user's screen is 1024 pixels wide by 768 pixels tall. And this wasn't always the case. Facebook, a couple of years ago, actually assumed a different monitor size, which was 800 pixels by 600 pixels. And a lot of websites did that, including maybe even CNN up until a couple of years ago. Well, as technology proceeds and as a lot of us start to acquire widescreen laptops, your screen resolution, the number of pixels left to right, top to bottom, increases. So even Facebook, a year or two ago, expanded its site somewhat to be wider. So why is this relevant? Well, at home, I'm sort of indulgent enough to have a 30-inch LCD, which means if I design CS50's website on my monitor, like you'd be scrolling left and right all day long because I would just assume that you have my monitor. But tools like this, Web Developer, let you do little tricks like this. I can click in the resize menu, 800 by 600, and it will just automatically make my window be the size of an older monitor, 800 by 600. So realize these kinds of tools can just save your help keep you sane. And actually, in this PSET5 surveys, one or more of you commented that you did have to scroll rightward on the course's website. And only by having that pointed out to us did we realize it. Frankly, I don't notice some of these bugs on my own monitor. And it was because we had made a mistake down below. And it was too wide. But look, we fixed it. Now it looks better. Anyhow. So let's actually do something here. So last week we looked at XHTML and PHP, and that gives us this ability to have a client interface with the server back and forth, and the server could generate dynamic output, thereby influencing the user's experience. And that's what PSET7 is all about. But we had no form of validation really, other than a couple of quick and dirty checks on the server side. And in PSET7, you'll know that it's a little annoying that if the user provides a bogus input, we encourage you just to apologize to them with the apology function, where you send a message saying invalid username, go back. Well, that's kind of annoying on a modern website if you have to, again, per last week's discussion, you have to go back and risk your form not even being filled out for you. You lose all of that data. So one of the very common approaches these days is for websites to use a bit of JavaScript. So JavaScript is also an interpreted language. So an interpreted language, again, is one that's executed line by line, top to bottom, left to right. It's not compiled into zeros and ones. So it looks like English, or it looks like actual source code. So in this case, JavaScript is a client-side programming language. PHP is typically server-side, but there's no reason you can't run it on your own Mac or PC. But typically it's server-side. JavaScript is client-side, which means when you visit a web page that has some JavaScript code inside of it, that JavaScript code gets downloaded to your browser along with the GIFs and the JPEGs, along with the XHTML and the CSS. All of it comes to your browser, so it's your browser's job to render, to display not only the XHTML and the graphics and all of that, but also to execute the JavaScript code, top to bottom, left to right. And so it's with JavaScript that you can actually enhance the user's experience client-side, and many of you probably these days completely take for granted a website like Google Maps, right? We can go up here and search for, we're at 33, let's do the Science Center, 1 Oxford Street, 02138. So this was a huge leap forward a few years ago when you didn't have to click these stupid up, down, left, right buttons, which then reload the whole page and show you a new rectangle. Reload the whole page, show you a new rectangle. I mean, frankly, most of us, and rightfully so, probably take for granted the fact that I can click and drag like this. But notice, if I do it fast enough, what seems to be happening in the top left corner? Yeah, so it's gray for a moment, and then it downloads. Well, this is what's called Ajax. So Ajax, asynchronous JavaScript and XML, it's more of a buzz phrase than anything, but it refers to the use of JavaScript, this interpreted client-side language, to fetching more information from a server and inserting it inside of the web page instead of forcing the user to reload their whole screen. So we actually do this, again, on the course's homepage right now. With regard to the big board, this thing updates itself every 30... Charles, doing well again. This thing updates itself, I think, every 30 seconds or minute. I forget what timer I set for it. But I thought it would be annoying if a student visiting the web page all of a sudden has the whole page refresh and it re-downloads all of that content, which can be slow, just to update a couple of values. So in fact, if we leave this page running, which I will in the background, it's going to keep updating itself in line. It's going to use Ajax and do this more seamlessly. So this was a huge leap forward because Google, when its competitors at the time were like MapQuest and Yahoo, completely left them in the dust with this feature. And you're coming to expect this. Facebook is much more Latin with Ajax these days, for better or for worse. And what this means is that you don't have to click and reload as many pages. Things just kind of update. A lot of people freaked out, I'm told, over this new live feed or something like that. Well, that's Ajax. The fact that you can see your friends, like status updates in real time, and they just kind of, I'm told they get inserted into the page and then kind of move the rest of the status updates downward. That's all happening inline because some people at Facebook wrote some code in JavaScript. They downloaded it to your browser by embedding it in Facebook.com's web pages, and it's getting executed by your browser. So let's see if we can't take a step toward that, because problem set 8 is going to have you play in exactly that seamless world of Ajax and JavaScript with PHP and MySQL. So here's a terribly simple form. Really didn't care so much about aesthetics this time, just functionality. I wanted to collect a user's email, their password. I wanted to get their password again, and I wanted them to agree to some terms and conditions. Why? I wanted a few different form elements here. But you'll notice if I fill this out, it's going to lead me nowhere very interesting. Let me go ahead and pull up Firebug, just because it's a little cleaner than looking at my own source code here. I'm going to go into body. I'm going to go into form. And notice, where does the form go? I'll zoom in here. What file does it submit to? What's the value of its action line? So dump.php. All right, so kind of a stupid name. It's meant to mimic a function we wrote for you for pset 7. So let me go into this. This is dump.php. This is not valid XHTML. This is not a legitimate web page per se. But for now, I just want to kind of experiment with this form submission to really understand how it works. So what I did was this quick and dirty, as we keep saying, script that apparently outputs a pre-tag, which means here comes some pre-formatted text. Display it in a monospaced font that looks like a typewriter instead of like an English essay. And then I have this, and actually I don't need this right now. I have print recursively the contents of $_get. So recall there's two ways, essentially, to submit data to a website from a form. Via get, which puts all your data in the URL, and via post. So what was a rule of thumb here? When would you want to use post instead of get? Any thoughts? So for privacy, right? So if you use get, by definition of it, remember that the queries end up in the URL. And that's how we sort of bootstrapped ourselves into re-implementing Google. We combined our our user's input with their get string, with their URL. But that's not so good if you're typing in private information, if you're typing in a username and password or credit card. So post hides all of that information. Post can also handle much larger submissions. So if you're uploading a photo, it's kind of hard to imagine uploading a photo to Facebook via just a URL and converting it to zeros and ones. That's also done via post as well. And as an aside, in case you've seen it in any of my code, request is another super global variable, as they're called. This has both the contents of get and post in them. So if you're being a little lazy or you want to support both get and post, you can access the same variables inside of request. But it's better designed generally to pick get or post so that you know what to expect. So that's all dump.php is. It's going to show me the contents of what was submitted by the form and therefore automatically put into that super global called get. So let's go ahead and do this. I'm going to type in mailin@post.harvard.edu, 12345, 12345. I'm going to check the box and I'm going to click submit. And what I get back here is this output. So again, this sort of indented output is the result of print r, and this is just what it does. It dumps the contents of an array. So what has been received server side? 4 variables inside of get. So if I really wanted get to do something more interesting, rather dump to do something more interesting, I could do something like this. I could do, let's say, name, colon, and then let's duplicate this. Let's say password 1. Let's change this to password 2, and then we'll change this to checkbox. So just to make clear what I'm doing, let's now put not the value of the whole array, but let's just print out $_get, quote unquote, email. Sorry, I wrote something down that didn't exist. I meant to say email. And then here, I want to say, quote, open bracket, question mark, print, $. So this is a little tedious. It turns out if all you want to do is print a value, PHP has a shorthand notation, which is open bracket, question mark, $, and then just put the variable that you want to put there, which in this case is going to be password 1. So quote unquote, and you probably get the idea, so I won't bother finishing the rest. But the point is, the top version is really just debugging. I'm dumping the whole array. If you actually care about individual values, you go after them using this associative array syntax, this square bracket notation. If I reload this page, thereby resubmitting the form, after saving my file, notice that what I get down here, oh, I'm cheating. I'm on the wrong server. Damn it. How best to fix cloud.cs50.net, mailin, source, forms. OK, let's resubmit. Mailin@post. 12345, 12345. Check the box and submit. OK. And it's a mess. Why is it all on one long line like this? Yeah, so no line breaks, so no BRs, right? So the quick fix here, and then we'll move forward, is put this there, this there, and now finally if I reload, OK. So again, sort of a refresher of what we did last week. So now let's take things up a notch, because right now, this program, if I actually go in here and change things around, like if I just say mailin, or something like this, or mailin@fast, or mailin@post. I don't give a valid email address. I just submit this. Well, nothing bad happens. It just gets submitted to the server. So now the server has to do all of the validation of this data. So that might necessarily be such a bad thing, because at the end of the day, that's the safest approach. Actually having your server defend against bogus user input is by far the most robust approach. But it's kind of annoying, because now I, the user, have to go back if I'm yelled at and I have to fix my form. Can't we give the user more immediate feedback and save them the time and the trouble of going to a whole new page and going back and forth and back and forth? Well, yes, we can. So in form2.html, we have the same form, but a little bit of magic. For instance, if I decide, you don't need to know this about me, I am going to proceed nonetheless, notice I immediately get yelled at. So it's a little small here, so let me zoom in. This is an alert window. It says, you must provide an email address. All right, well, where did this come from? Well, let's take a look at the page's source in Firebug. But again, you can go to view source and see the same thing. So open the body, open the form. Oh, this is interesting. What is a new attribute on the form element here that we didn't have a moment ago? So on submit. So on submit, kind of self-explanatory, because it says on submit. So when this form gets submitted, do the following. Well, it turns out that what should be done when the form is submitted is the following line of code should be executed. It's just long, so it wraps on 2 lines, but the line of code is return validate open paren, close paren, semicolon. So that's a snippet of code. It's not PHP code. It is, in fact, JavaScript code. So let's take a look. This is form2.html. So I'm just using HTML files. I'm not bothering with PHP. This is purely client-side static content right now. So let me scroll down all the way to the bottom. Here is the same form. So that is my form tag, my email word, password again. This is pretty much all old school now from last week, but the only difference is I added this attribute here. And again from last week, web browsers don't care about white space. I decided, this feels a little messy having it all on one line, so I just decided stylistically to put it on a new line, and that's fine. White space inside of tags like this is OK. So what is this validate function? Well, let's take a look. Well, even though last week we said the only thing that belongs in your head element is the title tag, kind of a simplification because you can also put a script tag. So this tag up here is kind of new. It says open bracket script. It then says, type equals text/JavaScript. That's just telling the browser, hey, here comes some JavaScript. So JavaScript is kind of the only language that people embed in web pages. There are other languages. There's VB script, which is a Windows thing. But pretty much these days, people only use this tag as follows. This is just a bit of syntax to ward off confusion. So long story short, there are certain characters on the keyboard that can confuse browsers very easily. For instance, if I wanted to say 2 less than 3, well, why is this kind of expression, if I type this inside a web page, potentially confusing to a browser? Just 2 less than 3. What's the scary letter there? So it's this thing, right? Because this is the special tag, the special symbol we seem to use everywhere to tell the browser, here comes a tag. Interpret this as XHTML, not as actual text. So for now, just know that this crazy syntax here, which is intentionally crazy because they figured who is ever going to need to write a sentence with these characters in it? So this thing here, who is ever going to need to write this in a sentence? So that's why it looks as crazy as it does. This just means ignore the following stuff. It is not XHTML. It's probably code or something else. So here's my first JavaScript function. Just like PHP, I say literally function. Then I give the thing a name, then parentheses, and inside of those can be any parameters. This time there's none. So what am I doing? Well, this function's purpose in life is to validate the user's input. So I could have done any number of things, but let's consider for a second, what could go wrong? What could the user do that might annoy me, the person trying to track this information? They might do what? Leave something blank. So leaving their email address blank, kind of useless if the point is to register them for something. What might they also do that's wrong? Passwords might differ. They might be too short. They might not have fancy enough characters. Or more simply, they might not match. Or third thing that we can pick on pretty easily, they didn't check the box, right? They didn't check the box. They need to check the box if I'm going to register them. So can we detect these things client-side? We can server-side. And even last week, recall, I used a couple of lines of PHP code to say, if this thing is empty, yell at the user. Make them go back. Well, here we're going to give them more immediate feedback. So here's the syntax. It's a little long, but that's OK. So I say if document. Document is the web page. It's a special global variable, if you will, that refers to the web page itself. Document.forms. Document.forms is an array, essentially, of all of the forms on the web page. Right now, there's just one, so this is pretty simple. Registration is the name of the form that I care about. Well, where does this come? Well, if you fast forward here, actually, there was one other attribute I added to the form, which we haven't used previously. I gave it a name, an arbitrary name, but one that's memorable to me. So now notice document.forms.registration is simply the JavaScript way of saying, go examine that specific form. What do you want to examine inside of it? Well, that registration form has a field called email. Where does this come from? We'll fast forward to the bottom and notice the name I gave to the input for email is just email. So be careful. The casing is important, but I did copy it literally, so we're good. And then finally, that's just the form field. If I want to check the value, I do .value. So document.forms.registration.email.value is kind of like stepping through a tree from top to bottom, deeper and deeper and deeper until you hit this value. And I'm just saying, if it is blank, if it equals the empty string, What do? Well, this is exactly what I got yelled at for before. JavaScript has built in an alert function. Looks a little different on different browsers, but at the end of the day, accomplishes the same task. It triggers a little pop-up with an OK button or the equivalent, and then just says something to the user. But I still want to ensure that the form does not get submitted. And so I return false here. And that's important because if you look back at the form tag, notice I didn't just call validate. I return the return value of validate. So the browser realizes, oh, if validate, the function, returns false, I should not submit this form. Let's just short circuit the operation and not let things pass. Well, what else am I checking for? Well, here's one thing. If the password is blank, I catch it there. If the first password 1 does not equal the second password, I catch that. If this, notice this is another property. So if the agreement input is not true for its checked property, then I have to say you must agree to our terms and conditions. So it's all fairly straightforward. Kind of long these lines, so I've allowed them to wrap, but pretty simple in the end. And finally, I return true if none of these problems exist. So if I go back here, and I do provide an email address, mailin@post.harvard.edu, 12345, 12345, but I don't want to agree. Submit, it still catches that, but I'm left on the same page. And notice the URL has not changed. I'm still at form2.html. I'm not at dump.php because I've short-circuited that process. So any gotchas? Is there a problem with using JavaScript in this way? What do you think? Especially if you're among those more comfortable or those familiar with web programming. Can I get away with just JavaScript and skip all that PHP stuff from last time? You know what the answers to these questions are always the same, right? No. Why? Right? So it turns out that just because you tell the browser to do something doesn't mean it has to do it. And a very common way of attacking or compromising websites is to take advantage of foolish assumptions programmers have made. If you only validate the user's input client side, or rather, if you only validate the user's input client side using JavaScript, well, what if the user is mildly clever and realizes they can go to Safari and they can go to disable JavaScript. They've essentially disabled all of your validation completely. So we can post on the bulletin. Oh, Charles, you're not doing. Oh, wait. Oh, my internet connection is dead there. Let's see actually how Charles is doing. Very nice. Okay. Okay. So anyhow, this is not a menu that comes by default with Safari. You have to enable it. It's very easy. Just email help@cs50.net, or I'll look it up at some point. I forget how to do it, but it's there now. So this is bad. Just using JavaScript, not such a good idea. And in fact, some bad things happen. If you disable JavaScript and try to visit any number of popular websites, they might work, though they might be a bit shot in the foot. Certain features might not work, or they might just not work at all. So people have started making assumptions these days when designing websites. If you don't have JavaScript enabled, the hell with you. Like, it's not worth, frankly, the time trying to implement two different versions of a website. And it's actually kind of a fun experiment, at least if you're so inclined, to disable JavaScript and visit your favorite websites and see which ones break, which ones take for granted JavaScript. Now, it's not all that silly to ask this because even though Safari on the iPhone is actually pretty good, it is a real web browser. Before this, I had a BlackBerry whose web browser sucks, frankly, and it didn't support JavaScript fully. So there were so many websites I couldn't pull up because they just didn't work. So though I make fun of this, this trade-off, it's actually a very real-world concern because who do you want to cater to? People who have JavaScript enabled and don't even know that you can turn it off, or do you actually want to cater to other devices that might not support JavaScript fully? Or do you want to deal with the really paranoid types out there who intentionally turn JavaScript off and hope and expect that the world continues to function properly? So these are the kinds of things that evolve over time, these mentalities and these features. So realize that validation client side, very useful in that it's saved me some cycles. I don't have to go reload the page and all of this, but it can be very easily circumvented, and you can take advantage of these assumptions. So this other tool I mentioned and showed very briefly last week is called live HTTP headers. So when you request a web page, what the browser essentially sends across the wire, across the internet, is literally something like this. Let me go ahead and use this program just to type something big. What a browser sent, if you go to let's say www.facebook, .com home.php, right? This is one of their common URLs. Well, what the browser really does when you hit enter is it opens an internet connection, a TCP/IP connection to facebook.com, and it sends it a request like this: get me/home.php, and use version like 1.1 of HTTP, the language that browsers and servers speak. There's 1.1, there's 1.0. That doesn't matter so much. So this is the message that's sent. Well, if you submit some variables to a website, now let's consider Google. So Google we've seen, so that was http google.com/search, and then $Q equals foo. So this is something I'm searching for. Well, what gets sent then to the website is this: /search $Q equals foo http/1.1. Well, notice this. It looks like I can submit anything I want to the server just by sending that message to the server. So if I don't care to execute JavaScript or I outright disable it, nothing's stopping me from still sending bogus data to a website. So let's take a look at this registration form. So this registration form lives at form2.html, and let's actually go back to the first version because it won't get in our way with JavaScript. I now have this tool up. I'm going to clear its window, and now notice. Let me move one to the side here. I'm going to go ahead and type in, let's clear this. I'm going to go ahead and type in Malin at post 12345 12345. I'm going to check the box and click submit. Notice this page got updated because what this little program is doing for me, this Firefox plugin, it's sniffing my web traffic and it's showing me what is the browser really sending to the server. So the very top is the URL that was just submitted to, and as we expected, it ends in dump.php. We knew it was going to go there. Then there's a question mark, so I'm at the very top middle of my screen. Question mark email equals Malin at post. The funky encoding is a browser's way of escaping input to make sure it's not confused for special characters. %40 is just a special character that means the @ sign. So no worries there. But ampersand is important because ampersand separates, remember, parameters from other parameters. So it looks like via get, what's been requested is that URL, which means if I now look at the line below, that is literally what the browser is sending to the server. It's this thing here, get/tilde-malin and all of this. And notice all of the form elements are submitted via the URL. So what's the takeaway? Well, if you have, for instance, a website, a bank's website, that's just checking people's usernames and passwords with JavaScript, and then if they're correct, they let them see that person's account balance, well, clearly could you circumvent that either by turning off JavaScript or just by sending data to the server? Actually, I'm telling the wrong story. I'm confusing my two stories. You can still send anything you want to the server, and if the server just assumes that the data's already been validated, they're in for some trouble, because clearly can you send most anything you want? And in fact, even though I'm still just using a plugin to look at this content, I can very easily request a website. In fact, let me do just this. So minor aside, just to show you how simple the internet really is. We use SSH a lot, but there's also a program called Telnet. So Telnet is like an unencrypted version of a browser. I can actually do Telnet, and then I can do a server's name. Let's see, I haven't done this before, so let's just try facebook.com. But Telnet by default has its own special port. It's 23, but I want port 80, because port 80, this is an internet thing, is a number that uniquely identifies the service we know as HTTP. Web traffic has a port number called 80. SSL traffic is 443. SSH, which some of you have even noticed, is what number? 22. So we've seen these kinds of numbers before, but just taken them for granted. I hit enter. Oh, I am connected to www.facebook.com. Now I have an interactive session. So what do I want to do? Well, let me go ahead and get/home.php. And I don't know much about the language. I'm just going to use version 1. And I'm going to hit enter twice. And OK, interesting. It looks like Facebook has responded with this. So this is an HTTP thing. If the server sends back that line, location : that's a redirect. That tells the browser, go to this URL. Well, I'm not a browser, so I'm going to have to do this manually. So let me go ahead and copy and put that in my clipboard. Now I'm going to rerun Telnet. So let's Telnet. This time I'm going, oh wait, let me, I got to fix one thing. Come on, quit. Let's see that once more. I copied too much of it. So I just want to get /common/browser.php. All right, so now I've copied that because that's where it's telling me to go. Let's rerun Telnet. Get this now, HTTP, whoops, enter. Look at that, facebook.com's HTML. So this is the mess that your website would, that your web browser would download. And let's just kind of scroll up, right? Like, so Mark's really made a mess of their website here. So look at all this stuff. Look, okay, let's find something familiar, my God, okay. But notice, so this is actually JavaScript. So this is intellectual property, because Facebook is pretty sophisticated with what it does client-side, all the fancy animation and all of that. But they don't really want CS50 students or anyone out there just copying their website, as has actually been done in other countries, and taking their code. So this actually is JavaScript code, but it's been, quote-unquote, obfuscated or compressed. So there are ways of not turning your JavaScript into zeros and ones, which is a lot harder to reverse engineer, but you change all the variables to funky names, so that it's really confusing what they represent. You eliminate, obviously, almost all of the white space. There's no new lines. There's no indentation. Now, frankly, this is only a slight measure of protection. So you can obfuscate your code in this way, but frankly, a smart person who really knows their stuff could certainly figure out what this code is doing. And there's plenty of tools that will convert this back to cleaner JavaScript, even though it can't recover the variable names. But this is the trade-off here. If you're sort of smart enough and adroit enough with JavaScript to figure out what this is doing, odds are you could re-implement Facebook in less time just by starting from scratch. So it's a trade-off. It just raises the bar, but this is another matter of security. Here we go, finally. So it looks like Facebook is using XHTML 1.0 strict, which is a certain flavor of it. Here is the tag we've been telling you guys to use. There's a couple more things there. Here's the head. There's some meta tags here, which are tags we don't care about. Oh, here's actually today's topic. So embedded in Facebook.com is all of this JavaScript. So long story short, what we sort of take for granted because we're pointing and clicking all the time with browsers these days is all very low level. And all of these details can be interesting and can be, again, exploited if you know how to send inputs to the server. So let's see if we can't be a little more clever here. That was form1.html. We saw form 2. Let's take a look at form 3. So form 3 looks like this in source code. This is the pretty code. The only thing I did differently is, actually I'm going to skip that because it's not interesting. Let's look at 4. I veto 3. All right, so form 4. So the difference in form 4 is that something just got grayed out, even though it's a little subtle on the screen. Yeah, so this is kind of annoying. Can't even submit. So right, this really annoys the user. Oh, but wait a minute. Oh, I checked that box, and now I can submit. So how can you do things like this? Let's introduce one more little building block and then see where we can go with this. So this is form 4. It turns out that this is the XHTML. It's pretty much copy and paste as before. And notice again, I am calling return validate on submission. But there's this other one here. And it's wrapping because my font is a little big. But notice you can also have an event handler, as it's called, a special attribute that actually responds not to form submission, but to clicking. So this says when the user clicks this checkbox, go ahead and call a function called toggle. Well, what does toggle do? Well, let's scroll back up to the top. There's a validate function. We're going to ignore that for now, but here's toggle. Interesting. So again, pretty verbose, but if document.forms.registration.button, that's the name I gave to the checkbox, .disabled. So if that is true, go ahead and make it false. Else go ahead and make it true. So it turns out that some form elements have properties, not just value, which we used before for validation, they also have Boolean properties like disabled. If disabled is true, it means you cannot click on that form field. You cannot fill out that box because it's disabled, so we can toggle it just by reassigning it a different truth value, false or true. So again, a tiny little building block there that lets us create, again, a more robust or more seamless interface. So why does this then get interesting that we can do things client-side? Well, this was just form validation. That's kind of an exercise in JavaScript syntax, nothing more than that. Well, it turns out we can use JavaScript to also go fetch more information a la Google Maps. So let's go ahead and type in here our favorite stock quote like GOOG. And click Get Quote. In every previous lecture and example, this form would get submitted to a PHP file and present the result, and I'd see the answer. Let me go ahead and click Get Quote. Oh, a pop-up. So still not all that impressive. So let's just look at version 2. There's a little teaser here. Now, OK, price to be determined. Now, again, I'm cutting corners on aesthetics, but GOOG. Let me go down here, click Get Quote. Now I'm updating the page dynamically, and my URL has not changed. And it's this very basic building block that really drives the fanciest, sexiest of websites today, whether it's Maps or whether it's Facebook or most any other site you visit. So more on this on Wednesday.